Hello, I'm Zishan Ahmed. I'm a sensor scientist at NIST. My team and I spend our days trying to create sensors.
What's a sensor?
That's a good question. A sensor is something that responds to a physical change in a way that we can measure. Ideally, you want it to be highly sensitive to just one thing. For example, carbon dioxide or hydrogen. In our lab, we have been thinking about ways to detect chemicals.
So how would we do that?
Well, a straightforward way would be to use some kind of a sponge that sucks up one specific kind of chemical and nothing else. In our search for such a sponge, my team and I learned about a fascinating class of materials called metal organic frameworks, or MOFs. MOFs are combinations of metal and organic molecules, and they're not typically used in sensors. We like them because they're lightweight, easy to make, and very selective. There are different kinds of MOFs, and all of them have molecular structures that like to capture certain things. One kind of MOF, for example, likes hydrogen gas. One other kind of MOF likes carbon dioxide. Once a MOF has grabbed its favorite molecule, it holds on to it. We began to wonder, could we make something useful from them? We realized there was a problem with MOF. By themselves, MOFs couldn't be placed on a sensor. We needed a way to embed the MOFs in a usable solid material. It turned out the answer was plastic. Specifically, the kind of plastic used in a 3D printer.
Why plastic?
Plastic lets many gas molecules pass right through it. So if we can embed MOFs in the plastic using a 3D printer, the MOFs can then grab the gases we want to detect or use, gases like hydrogen or carbon dioxide. The MOF that likes carbon dioxide won't suck up the hydrogen, and MOFs that like hydrogen won't suck up carbon dioxide. Because MOFs are so selective, we can mix the right MOFs into the plastic and start to think about doing other cool things. We could mix in one kind of MOF and create a better way to store hydrogen for tomorrow's fuel cell-powered cars. Or we might use the kind that likes carbon dioxide or methane to detect greenhouse gases that contribute to climate change. We're still working on how to combine all these ingredients, so the idea isn't ready for prime time yet. But we are doing the measurement science that will get us there. We're exploring how MOFs behave in the 3D printed plastic. And that's what science is all about, questioning and exploring. And with our thorough testing and experimentation to follow it up, who knows what can happen.
As a scientist at NIST, and this is how you break it down.